For this problem, we're going to solve a logarithmic equation. Here we have log base 10 of x squared plus 3 equals log base 10 of x plus 6. We need to recall that if we have logs with the same base on both sides, log base a of u equals log base a of v, then we can set the insides of the logarithms equal to each other. In this case, we do have logs with the same base on both sides, so we can set these insides equal to each other and solve the resulting equation. We'll have x squared plus 3 equals x plus 6. We've got a quadratic equation now. We'll bring everything to the left side, let the right side equal 0. We'll have x squared minus x minus 3 is equal to 0. We want to solve this equation by factoring, if possible. We look at this, it doesn't appear that factoring will work, so we can use the quadratic formula. A equals 1, b equals -1, and c equals -3. If we plug these values into the quadratic formula, we get x is equal to 1 plus or minus the square root of -1 squared minus 4 times 1 times -3, all divided by 2 times 1. Look at this 1 plus or minus the square root. If we evaluate this inside, we'll have 1 plus 12, which is 13, and then denominator will be 2. It's important when solving logarithmic equations that we do check the solutions that we get, because sometimes doing operations on our equations can yield extraneous solutions. In this case, we have 1 plus or minus the square root of 13 divided by 2. If we put that in our calculator, we'll see that x is approximately -1.3 and x is approximately 2.3. If we use those and check up in our original equation, you can see that neither one of those values will yield a negative value inside the logarithm, nor will they yield 0, and so both of these solutions will work. So our solution set will be 1 plus or minus the square root of 13 over 2. Now that we've solved this equation algebraically, let's use our Smartboard interactive whiteboard to solve it using a graphing utility. To solve our equation, we notice that we have expressions on both sides of our equation. So we'll enter our left side at y1 and our right side at y2, and we'll look for intersection points. We go to our graphing calculator. In y1, we want to enter the left side, which is log base 10 of x squared plus 3. Close parentheses. And in y2, we enter the right side, which was log base 10 of x plus 6. Close parentheses. And we'll graph this using our standard viewing window, -10 to 10 in both directions. See the graph of y1, and then here comes the graph of y2. It looks like they might be crossing someplace in the middle, but we don't have a really good view, so we're going to have to adjust our window settings. And notice we have a lot of white space that we really don't need. We don't see any intersection points over here, and it doesn't look like there will be any out this way. So we're going to narrow our field of vision to this middle region. So we'll go to our window setting, and we might cut that down x min to -2, x max maybe 5, and we use a scale of 1. For y min, let's use -2 and a y max of 5. And let's graph that. And we see our graph for y1. And here we see the graph of y2 coming through, and we see 2 points of intersection. We get one point over here in the negative side, another point over here in the positive side. We're going to find those 2 points of intersection. We go to our calc menu. We're going to pick option number 5 for intersect. First curve, we're on y1, so we'll just hit enter. Second curve, we're on y2, we'll hit enter. And now we need a guess. We're going to find this first intersection point over here on the left, and it looks to be somewhere near -1. So we're going to use -1 as our guess. Hit enter. And so we get an intersection point at roughly -1.30. I'm going to go ahead and drag that over. Come back to our calculator and find our other intersection point. Go back to our calc menu. Pick option 5 again. First curve is y1, so we hit enter. Second curve is y2, so we hit enter. And this time we're looking for the intersection point that's over here on the right. It looks to be somewhere around 2, so we'll use 2 as our guess. Hit enter. And this intersection point looks to occur at x roughly 2.30. Drag that one over as well. Make that a little bit bigger. So we can see from our graph that we have the intersection point at negative 1.30 and at 2.30. That makes our solution set for this equation negative 1.30, comma 2.30.